Hey everyone, this is Mr. K, and today we're going to do some practicing solving using logarithms or logs. These will, again, there are different situations that will come up, but these are probably going to be the most common. The first one would be, let's say that we have the log base 2 of, we'll say, x plus 4. Let's say that that equals 5. So what you can do is you can use the log rules, and you can actually convert this into exponential form. If you need assistance with that, I do have another video on that you can check out. But so we're going to convert this to exponential form. So this is going to be, we're going to rewrite this as 2 to the 5th power, and that's going to equal x plus 4. So whenever you have the x inside of the logarithm there, you're going to want to get it out of there by converting it to exponential form. And so if you do 2 to the 5th power, that should be 32, and that's going to equal x plus 4. And now it's just standard algebra that hopefully you're experienced with, and you subtract 4 on both sides, and you should get x equals 28. Another example of something that might come up was, let's say that the x is in the base. So if I had log base x of, we'll say, 25, and that equals 2. Again, we're going to have to convert this to exponential form. So I'd rewrite this as x squared, or x to the 2nd power, equals 25. And now when you solve this, I would square root both sides, and you would get x equals, now normally when you square root both sides, you'd say, okay, let's not forget our plus or minus, but because you can't have a negative base here for a log, we're going to be left with just the positive answer, which would be positive 5. One other thing, or really two other situations that will come up, one's pretty straightforward, one's not so straightforward, is let's say that I have something like 2, and then we'll write log base 6 of, say, 8, and that equals log base 6 of, let's say, 2x. We can use a couple of different rules. One rule is the one with exponents, where I can bring this in as an exponent. And so I can write this out as log base 6 of 8 squared. And that's going to equal the log base 6 of 2x. And now whenever you have just a log of something equals a log of something, you can actually just drop those logs, because whatever you're taking the log of, as long as it's the same base, whatever's on the inside there has to be equivalent to each other. And so you end up with 64 equals 2x, and so then I can divide both sides by 2, and I'll get x equals 32. Sorry, I didn't realize the camera was not focused. So that's the work for that. If I slide over to the side here, one other situation that could happen is like if you need to combine logs together. Let's say we had the log base 5 of 4 plus the log base 5 of, we'll say, 3, and that equals log base 5 of, I'll say, x minus 7. What you can do is, when you're adding two logs, this is going back to those log rules, we can combine these into one log. So if I combine them into one log, I'm going to get the log base 5 of 4 times 3 is 12, and that's going to equal the log base 5 of x minus 7. And so now, just like we had before, if I have two logs equal to each other and they have the same base, I can drop the log, and you end up with 12 equals x minus 7. And now again, standard algebra type stuff, add 7 to both sides, and you should end up with x equals 19. So there's just a couple of quick situations how you can use logarithms to solve for x. Oh, one more situation. Hey, what happens if x is in like an exponent? So let's say I had, we'll divert this off here a little bit. Let's say I had 2 to the x power equals 15. Logs and natural logs we can use to get the x out of the exponent. I'm going to use regular log for here, so what you're going to do is you're going to take the logarithm on both sides. And what that does is we'll end up with the log of 2 to the x power equals the log of 15. And now because we have a logarithm now, we can take this exponent and bring it out front. And so what this ends up being is I can write this out as the x times the log of 2, and that's going to equal the log of 15. And now if I want to solve for x, I can divide both sides by the log of 2. And you end up with x equals, and then that's just going to be stuff you type into the calculator. I can do that for you. If we bring this in, if I have the log of 15 divided by the log of 2, I end up with 3.91, we'll say. There's about. Another way you can do the same exact problem, I'll go up to the top here. I know I'm kind of running out of space. If I did 2 to the x power equals 15, another thing that you can do is you can actually write this in exponential form. Come on, camera. So if I want to write this in exponential form, remember converting back and forth between the two, I can write this as log base 2 of 15 equals x. And now it's just, can you type this into the calculator? So I'll bring the calculator back. To find log base, if your calculator is going to have it, you can press math, use the up arrow, and you should see at the bottom there, log base. If you press enter on that, now I'm able to actually enter in base 2, and then the log of 15. I end up with the same thing, the 3.91 that we had before. So that's just another way of solving that same thing. Thanks for sticking it out with me. I hope you have a fantastic day, and I hope that this video helped. See ya in the next one.